Okay, I made a really simple error. When I put in my v squared, v was this, and then I have to square that. That was my mistake. So when you have a power on a power, you multiply them, so that becomes cosine x to the fourth. And then I can reduce this because it's not a sum or a difference. I can reduce out a cosine with a cosine. So I'm left with 2 times sine x cosine x to the third. So let me write that again. 2 sine x over cosine cubed x. There's the final answer. Okay, I also did it using the chain rule, so I'm just going to show that to you in case you wanted to do it with the chain rule. What I did with the chain rule is I rewrote 1 over cosine x squared. I rewrote it as cosine x to the negative 2. Okay, so here was my function, y equals, if we're using y. Okay, so I rewrote 1 over cosine x squared as cosine x to the negative 2. So then my u is cosine x. The derivative of that is negative sine x. And then if this is u, I can write u to the negative 2, u to the negative 2. The derivative of that is I bring down my negative 2, minus 1 for my exponent, which gives me negative 3. And then I multiply these together, negative sine x times negative 2 times cosine x to the negative 3. I substituted in my u. Okay, so I did this times that, but I went ahead and did the substitution. And then a negative times a negative is a positive, so here's my 2. And then I have sine, and then this part with the negative exponent, I moved it to the denominator. And that gets me the same answer as I got when I did it with the quotient rule. So I actually do prefer the chain rule on this one. I think it has fewer steps, but it does work if you do the quotient rule. You just got to be careful that you don't make the same mistakes that I made, which was the v squared. I did not square my v, because v was cosine x squared. I forgot to square my square. And you do end up with the same answer whether you use the quotient rule or the chain rule. That's the answer. So that's the second derivative of f of x.